In this final section on the male reproductive system, we're going to learn about spermatogenesis and spermiogenesis, which is the process of making new gametes. So we have to start before spermatogenesis inside the seminiferous tubule, where we have the germ cells for spermatocytes known as the spermatogonium up there near the outer wall. As they mature, they go closer to the lumen, so by the time you have a sperm with a flagellum, it's in the right location to travel. And so what happens before this process is cells that are there aren't going to live your entire life. So they're going to have a normal cell cycle and undergo cell division mitosis. And when they undergo mitosis, these germ cells produce two different types of spermatogonium. The first type is going to stay behind, and it is the cell that will then undergo mitosis to create two more cells. So here's the thing, if one cell makes two cells and both cells become sperm, then there's nothing left behind. So this is why one cell makes two cells and one stays behind. The type A stays behind. The type B one is then the one that will become the cell that is the gamete. So in the process of spermatogenesis, mitosis is not part of it. It is before the spermatogenesis. So the type B will then enter meiosis 1 and become a primary spermatocyte. So just like the normal picture on the left, we're going to have a primary spermatocyte enter meiosis 1. We have two cells come out of that. They are secondary spermatocytes. I want to point out, do you see that they are attached to each other? Yeah, in the male, it's weird. These daughter cells never separate, okay? They're always attached to each other. And in meiosis 2, they are going to, each of these is going to form two daughter cells. So we will have 4 cells, all of which are attached to each other, and then become these things that look kind of like badminton birdies with tails called spermatids. Okay. So that's in the cartoon drawing of just what's normally happening. Now, if we stick that inside the male reproductive system, we can see the spermatogonium at the surface giving birth to 2 cells. 1 continues along the pathway, becomes a primary spermatocyte, produces 2 secondary spermatocyte, which produces 4 cells at the end of meiosis, which can become 4 spermatids, which originally are all attached to each other. So where does all this happen? This actually happens inside a substentacular cell, that Sertoli cell, that nerve cell. So this cell has a lot of different functions. It is the nourishment for these cells in this process. It takes time for this. It does not undergo this process, you know, in 10 minutes. It takes some time. This cell, recall, is the one that also regulates sperm production because it produces that androgen binding protein. So if there's decreased levels, you're going to have less sperm production. And in addition, the substentacular cell forms our third cellular barrier against blood. In this case, we're going to call it the blood-testis barrier. And so we have these junctions right here. By now, you should know which type of junction is going to be forming this barrier. So what happens is when the spermatogonium undergoes mitosis and you have the type A being left behind, the type B here, these junctions will open and the type B spermatogonium can enter, and then the junction reforms. Okay? And then that type B cell undergoes meiosis 1, meiosis 2, into the spermatids, then eventually into sperm. So why do we have this barrier here? Because if white cells came along and saw these cells with their odd number of chromosomes, they would try to destroy it. The natural killer cells would go to work, the macrophage would go to work because they would recognize that these cells are abnormal. So these cells are protected from that. And in case you're wondering where this picture came from, this picture is the exact same picture here on the right side, just turned sideways. Okay. So let's talk about the plastic surgery these cells need to undergo, because when the cells are formed, they are round little cells, which are not good for swimming. So the process of the plastic surgery or transformation from a normal looking cell into a motile sperm is called spermiogenesis. So this is the final stage in spermatogenesis, where the spermatid will become motile spermatozoa. So the first thing that has to happen, that set of quadruplets, they need to separate. Each sperm is its own potential boy or girl, okay? So those daughter cells will separate from each other. They change shape. Instead of being round, they're becoming a little bit oval. Notice that the nucleus becomes a cone head. All the lysosomes in that cell will coalesce together and form an acrosome, which covers the cone head part of the nucleus. We're going to get rid of pretty much all the organelles because the cell's not going to have to do a whole lot except for make ATP so it can swim and then trigger cell division. So yes, it's going to keep all its mitochondria and it's going to pack them on the opposite side of the nucleus than the acrosome is, because the nucleus is streamlined for swimming. It's also going to bring a little centriole along with it. And so then it gets rid of all the extra cytoplasm and plasma membrane, and it has a lot of microtubule formation so that it can have a nice long flagellum. However, even though it is formed, recall it's not going to move under its own power until ejaculation, and it's free in the world. Does not even move under its own power during ejaculation. Everything has to do with sympathetic smooth muscle contraction to get it outside. So that's its formation, and then it does some maturation in the epididymis. So spermiogenesis takes about 64 days. Then the sperm spends at least 2 weeks maturing epididymis. Okay, they're not ready for duty the week of Valentine's Day. I apologize. That's if you were taking this in the fall. It'd be ready for Valentine's Day. For you guys, it's going to be ready around Halloween. So if you're having sex around Halloween, then you just need to recall that the sperm were made during your finals week in the summer. So looking at one sperm up close, we have the head, which contains the cone head nucleus, as well as the acrosome with all of its digestive enzymes. We have the mid piece, which contains a lot of mitochondria plus centrioles, and then we have the tail, which has the flagellum. So this is the picture we show all the time. Beautiful little sperm over there. When in reality, yeah, here's a drawing, but this is actually real sperm where different stains, fluorescent stains have been given to so that you can tell the heads from the tails. I don't know why, but obviously a bunch of these sperms have decided they're going to do a square dance right there in the middle of it. And then we have, like at 7 o'clock, that tail with a super short, that sperm with a super short tail, and this one's super short. Okay, they're not making you pregnant because they're not getting anywhere close. This one's got a little circle tail, so I guess it's just going to go around and tail. In other words, there are a lot of abnormal sperm being produced, and that's why he needs to make it a day, because like some have 2 heads, some have 2 tails, some have 2 heads and neck, some have curly tails, some have forked tails. In other words, there's a lot of, it was made for volume, not quality control. Not quantity, not quality. Sorry. So this is the way things go. You hit puberty, you start kicking out tons and tons of androgens, testosterone, everything's hunky-dory until you hit your 40s. When you have your midlife crisis, you get your younger girlfriend, younger wife, your sports car, whatever, because you can see mortality in the future. Your hormone levels have dropped about 25, 30%, and it keeps that way until you hit the male menopause, which doesn't occur in the 80s. So yes, gentlemen, you can become fathers in your 60s or 70s, but my question to you is why? Why would you want to? Think how you were as a teenager. Do you want to be dealing with teenagers in your 60s and 70s? Think about it. All right, so last thing for you to do, figure out what kind of photograph this is, figure out what all the things are pointing to. That's your job to figure out what their names are and what the functions of each of these are. And with that, we are done with the male reproductive system. I want to thank you so much. And I will see you for our final topic, female reproductive system. Thank you.